So far we have encountered three different data structures, and those are vectors, matrices, and arrays. And so far there are two different things that we can put into a vector, a matrix, or an array. The first thing we can put in there is a numeric value. The second thing we can put in there is a complex number. And what we're going to introduce in Chapter 11 here is a third thing that we can put into a vector, matrix, or an array, and that is a character string. As a bit of a review, the term bit is used by computer scientists to describe one binary digit, and that will be in one of two states, either a 0 or a 1. A byte is 8 binary digits strung together, and by the multiplication rule there are 256, 2 to the 8th power, 256 different possibilities for the number of different bytes that can be represented by a string of 8 binary digits. And finally, ASCII is a commonly accepted form for what these various strings of 8 zeros and ones represent, and that's the American Standard Code for Information Interchange. And there are certain values that are accepted, for example, characters and numbers and certain types of punctuation are all in there. And that's how computers communicate back and forth. So I'm going to start out at this point by setting x equal to a string. And I've decided to put it in double quotes here. And that is going to be a character. And when I hit return, you can see up here there is a object x which has been created, and what's sitting in that object is just a vector of one element, and what's in that element is the character string of just the letter R. So if I were to come back into the console window here and type x, you will see it's a vector of length 1 that is R. Then I can overwrite that if I want and put in S on top of it. And here I'm using single quotes, and double quotes and single quotes, either way, are going to set this to a string S. Now, one thing I can do at this point is I can call a function which can be used on strings, and it's called nchar. So I can say, how many characters are there in the object x? And it turns out there's just one character, and in this case it's the character s. But I can also take x and set it to something a bit longer. So this time let's go with hello world. And now if I type x, there is hello world. Again, it is a vector of length 1 still. But I can come back and then ask how many characters are here, and there are 12. So let's count them. There are 5 in hello, and then the 6th character is the space, and that counts as a character as well. Then 7, 8, 9, 10, 11, and then finally the exclamation point is a 12. Each one of those characters has an ASCII representation to it. There is another function which I can call, and it's the substring function. And I can take x, my hello world character string, and I can say where I want to start. And I can start, for example, at position 3. And then where do I want to end? That is the stop. And I could go with maybe 10 there. So you'll see what happens. It will cut out the first two letters, the H and the E, and it'll also cut out the last two characters, which are the D and the exclamation point, and just leave those 8 characters in the middle that you see there as a substring. Now this has a lot of nice applications in what is known as text processing, because what you can do is you can take in a document of any kind, and you can do all kinds of calculations in terms of how long are the words and that type of thing. easily using functions such as these. All right, on to another example. I can set x equal to, now put this in quotations, and I'm going to say \122. Well, I happen to know that \122 is the octal representation of the letter R. So if I now type X, it's been set to the letter R. And you can see that's up here in the corner as well as down below here. So you can put a backslash into a character string followed by 3 octal digits, and that will give you a particular character, and in this case it would be the letter R. Now at this point I can print X if I'd like to, and I get it just as I did when I typed X itself. But there is another way of displaying the contents of an object, and it's the cat function. Notice in this case the cat function will strip off the quotes, and it will not treat it as a vector. It will just display it flush left. So if that's ever of interest, that is the cat function, which is short for concatenate. Let's try one more. I can say cat, and then I can put in quotes a \t, followed by x, followed by, again in quotes, a \n. And in this particular case, when I hit return, you'll see what these stand for. The \t stands for tab, and that moved the R outwards a little bit. And then after the R was printed, we put a \n. The N is for new line, and that basically puts in a carriage return and returns us back to the prompt. So those might be useful to you down the line. Here's another example. We might set x equal to, we now have a bunch of different data points, or data types. So one of them is a string. Here is a 4.7. Here is a -8. Then we could also put in 6.02 e, lowercase e, 23. And maybe we can put in pi. Oh, one more. Let's put in a complex number, 2 plus 3i. So there we have a mishmash of a whole bunch of different data types, and it turns out, I forgot my C up front here, turns out that R does not allow different data types to be put together in this fashion. It's got to do something with that. So when I hit return, X will silently get set to those values, but it cannot mix a character string and a numeric and a complex all in one vector. Vectors, matrices, and arrays are all known as atomic data structures, and they can only accept values of the same type. So rather than giving me an error here, what R did was it coerced all of these different values to all be strings. So now this one has become R as a string. The 4.7 got automatically coerced to a string, as did the -8, as did the 6.02 times 10 to the 23rd, as did pi, as did the character string, or I'm sorry, the complex variable. All of them got coerced into character strings, and this is something in R that's known as automatic coercion. One last topic, there are certain character strings that are built into R, and I'll give you a couple examples. Here's the first one. Letters. Letters is a vector of 26 characters, and they're the lower case letters. If you put that into uppercase, you will get all of the uppercase letters. If I want to pick one of these off, for example, if I want to pick off the 18th element of letters, it'll pick off the capital R. There's another built-in character string, month.name. This is a vector of the 12 month names. Month.abb will give you the month abbreviations. If you want to see month abbreviations and you want to look at number 6, whoops, I didn't mean to put an S in there. It'll give you just June. Then there is state.name, and this will give you the abbreviations, or I'm sorry, the names of the 50 states. Then, of course, there is state.abbreviations, and there they are. Notice that these numbers here are designed to be helpful for you to pick off what number a particular element is. For example, if I want to get the state abbreviation for Virginia, I could just type state abbreviation sub 46, and I'd get the abbreviation for Virginia. So the next thing that is up is we're going to take a look at some functions that can be applied to character strings.